Let's look at doing the paper pull lab. This is the lab Anisotropy. I'll get that out. And anisotropic means that the properties of a substance are different in different directions. And to show that today, we have paper cut along its length. This is an 8.5 by 11 sheet of paper that we cut lengthwise, and then we cut several sheets widthwise. So this is against the grain of the paper because the grain tends to run with the long edge of the paper. And this is, the grains are lined within. This test requires several different pieces, one of which is done on the MTS. The rest are done with visual inspection tests. But we're just going to concentrate on the testing here on the machine, the tensile test. What we want to measure is we want to measure the breaking strength, what's the load it takes to break that sheet of paper, and how far does it elongate. And that's exactly what this machine does for us. The MTS is very, very good at doing those kinds of measurements. Now to set it up, we said that the gauge length, and remember gauge length from your manual is the length of the test specimen, is 6 inches. So we want 6 inches between these two pieces. So I'm just going to use a simple ruler, doesn't need to be fancy, and you'll see I'm at about 4 inches. And I'll use my, turn it on here, there we go. Got the green light, good to go. And I'll take it up to 6 inches. And that's pretty fast, so I'll dial the rest of it in by hand here. Maybe a little notch, there we go. And dial the rest in, that's too much. Down, look at that, 6 inches. Now, I don't want to have to reset this every time. Over on the side of the machine are knobs. So now when I run this machine up, there we go, run it up, if I hit return, it'll go down, and notice it locked. Did you hear it click? So the machine will go no lower than this, and I maintain my 6 inches for the start of my sample. The sample is mounted between the jaws. The jaws are tightened with a wrench. Software should be running before we start this. So let's go to our custom templates over on the PC. We are doing the paper pull. There we go. We'll give that a moment. And why don't I make that full screen, maybe make it a little easier to see. You'll notice that on the bottom is a load, and the crosshead is presently set at just under 5 inches. Well, we need to reset those, so how do we do that? Well, it's Windows, so we right-click, and that brings up our options, and we say 0 the signal. And we do that on both of these. So now I know where 0 is. I've locked it in manually with my thumb screw dial, and I have it set here on the machine. I'm going to take over by clicking on this blue arrow with the back arrow here. I turn down the machine, and it now controls the system, and you'll see that all my controls are active here on the computer. So I turned off the hand dial at this point, and if you look at it, you'll see there's a red exclamation point that's lit up, and that's telling you that it's not in control anymore. So now the test is being completely controlled by the computer. And we're good to go. So we need to mount our specimens and then pull them and measure the deflection and measure the force at breakage. And the software is very good at this. So let's start with a nice longitudinal sample. And you can see it's 11 inches long because that's the length of the paper, but it doesn't matter. We're only going to test. And you can see that, oh, that's a little long. So you know what? Tear an end off. Make it fit. Because remember, it only is going to go match the 6 inches between the two sample ends. That's the gauge length. The rest of the paper is just there to be held. Get it lined up best you can. And then kind of thumb tight best you can the two plates together. Okay? And there's going to be a little wobble in there. That's okay. Now we need to tighten it. There is a word in the English language called finesse. You are not Hercules. You do not need to be Hercules. This is paper. It'll tear. So I hold the specimen, put on my wrench, give it just about 1/8 of a turn till it comes snug. That'll be enough to hold it. That'll give us 100 pounds of grip. Ditto down here. Make it tight. Don't want to slip through, but I don't want to tear the paper either. That'll ruin the experiment. So now we're set up. You can see my load is nearly 0. Why is it bouncing? No, because the transducer is very, very accurate, and it's measuring changes from us walking around. Grip separation, 6 inches. Test rate, you don't need to worry about. That's the speed of the pull, 0.033 inches per second. Data acquisition, 100 hertz. That means every second we're taking 100 readings. The width is 1 inch. So let's set that to 1 inch. Just simply enter that in the keyboard. And the thickness does not matter. We're not using it, but the program asked for it. This 079 is roughly this paper. I have that pre-put in. You're good to go. Now, what we're going to do is hit the green run button. And what it's going to do is move the MTS head unit upwards at a 33 thousandths inch per second. And it's going to measure the load and the position of the crosshead. And when it breaks, the paper that is, the experiment will stop. Let's see if it works. Let's hit the run button and run the test. And it asks again for our information. Just one more time. In case you forgot to put it in the first time, I'll accept it because I already pre-put it in. I'm good to go. And here we are. You can see the curve going up, the load increasing. Looking great. We're up to about 11 pounds. The paper snaps and the experiment finishes. And it creates this sawtooth curve. The load goes up as the head pulls up, and we'll accept that and return to 0 and say yes. And the head goes back to 0. And our experiment is done.